Thank you. Welcome back after lunch, right? So everyone is ready for the after lunch dip. Snoring is not allowed, right? Except if it generates data that you can leverage from medical use cases. Um, I'm proud to invite one of our residents. What I remember started very small, and interestingly, when I was working for a former semiconductor company, I still remember Fabrizio walking in with an idea around some kind of AI acceleration chip platform. Unfortunately, I couldn't grasp the idea back then. But I think if you look on social media and what the company has been achieved recent years and have been able to tape out slash deliver already a solution, a platform I need to call it right, it's great to have them here. So I want to give a warm welcome to Bram-Ernst Verhoef, who is co-founder of Axelera, who's one of our residents. And I don't dare you to call you a scale-up anymore. So welcome.
Wow. Okay. Nice compliment then. Uh, yeah. So pleasure to be here. So I'm a co-founder of Axelera AI, where I'm leading the machine learning efforts. And today I would like to talk about how the next wave of AI is fundamentally changing the way we live and work. And when I mean the next wave of AI, it's really about generative AI, because this type of AI is relatively recently really giving a lot of opportunities and already changing the way we are working. And before I go into this topic, I would like to ask you one question. Who here has already used a generative AI tool? Raise your hand. Okay, great. Yeah, a lot of people. Awesome. That kind of fits also with a recent survey by McKinsey, where they found that about 80% has already tried the generative AI tool, 22% is regularly using it already. And of course, it's a little bit more in the more taggy kind of professions. But overall, this is really a good number and representative of what you are here. So, question then is, what is generative AI? So most of you already have a good feeling about this, right? What is this? But often when I hear or ask for a good definition, I just hear that, yeah, this is an AI model that generates something. But really, every AI model actually generates something, and it's not so really clear then what's meant. So I would like to briefly go into this direction, so that we're all on the same page. And a good way of introducing generative AI is to contrast this with more discriminative AI. And discriminative AI is maybe a little bit older type of AI, where the goal is really to classify, and it's still frequently used. But the goal is really to classify between different kind of categories. For example, images of cats and images of dogs. And the goal of the model is really to find discriminative features, so features that really make it easy to classify between these different kind of classes. So this can, for example, be the shape of the head, type of fur, and so on. And if you look at these models and how they do this, it's pretty interesting. So these models have different kind of layers, and if you check the representations of these images in different kind of layers, you'll see that in the initial layers, these representations for cats and dog images, for example, they're really entangled, and it's really hard to classify between them. But if you look towards the later layers of these models, you can see a nice, does this work? No. Separation between the different kind of representations for different kind of classes. And at this point, it's really easy to just draw a line or a plane between them, and you say, well, everything on top is an image of a dog, everything below the plane is an image of a cat. So that's discriminative AI, and the nice thing about this is actually that things are similar inside the brain. So this is actually an image from a neuroscientific paper, but it also holds for these AI models. So a nice similarity here going on. So this is discriminative AI. Now looking at generative AI. And here the goal is not to really find the discriminative features that allows us to classify different kind of images, but really to model the whole distribution of features. So everything that is to know about images of cats and images of dogs. And why would we want to do this? Well, in a later stage, once you have a really good model, you can then start to sample from this model and generate new images of cats and new images of dogs or something more interesting. So how do these models do this? Well, these days, most of these models, they make use of transformer blocks. And transformer blocks is a small type of neural network that learns to pay attention to the most relevant parts of its input. So I'm not going into the mathematical details here, but I think to get a good understanding or intuition about how this is working, there's a nice study here being done where they, here there are 3 paragraphs, and they're almost the same. The first 2 paragraphs are being read by human participants, and they indicated where they paid attention in order to complete their tasks. Then the AI model did the same kind of thing, also read that paragraph, and also then we could then look at where the attention was being given. And if you look at the words that are being attended, both for humans and for the model, you see that these are very similar. So what these models have learned is really to pay attention to the most relevant parts of the input text in order to complete the task. So that's the main block these days of these generative models. And actually, if you look at the most well-known generative AI models, like Stable Diffusion, for example, this is really how they work. They really consist of stacks of these transformer blocks. For example, Stable Diffusion, there are 2 types of, 2 networks actually. There's the image generator network in orange in the center, and then there's also the prompt network. And in both networks, you have these transformer models that are really processing data. So for the image generator network, that's pure noise, that is the input. So it's just black and white kind of dots. And it then transforms this noise into a real image. But if you have used already Stable Diffusion, you know that it generates an image according to the prompt that you have provided. So during the image generation, the model is constantly paying attention to this prompt, this input prompt, and in doing so, it can really generate the image that you want it to generate. So for example, a cat in a medieval harness. That's one of the examples. So that's how Stable Diffusion works. And actually, large language models, it's like the Llama, the GPTs, the Bing Chat, and so on, they all work in similar ways. Also, stacks of transformer models that process the input. And the really particular thing about these models is that they are trained on lots and lots of data, basically the whole internet. And what these models only have to do is to predict the next word given all the previous input that they have seen. And it turns out that this really simple training recipe actually causes a lot of nice behavior that we can use in various kind of tasks. And we will see a lot of the examples later on. But a good example to if you want to look at what is possible if you start to mix and match these kind of networks is given over here. So here you will see Tim Cook, CEO of Apple. He will give an English speech, but this English speech is then first converted to English text by an AI model. Then this English text is translated into Hindi, and subsequently the Hindi text is then back converted into speech, but with the same voice as Tim Cook has. And then finally, the image itself is also changed, modified in such a way that the lip movements are synchronous with the new Hindi speech, so that it looks really realistic. And this then looks like this.
स्थानांतरी प्रारंभिक बड़ा कमान है जिसका महत्व अत्यंत बड़ा है और इसके बारे में बहुत कुछ जानना आवश्यक है.
So that's Tim Cook speaking Hindi. And I have no idea whether this is correct, but I trust the AI here. So this is some of the cool applications that you can do with this generative AI. And you can imagine that you can use this kind of capabilities in simultaneous translation or augmented reality applications and so on. So that is the introduction into generative AI. And before I go into the multiple use cases of this type of technology, I would like to briefly go over some of the problems related to this, so that we have a fair understanding of what these models can and cannot do. So the first problem, well known, is these hallucinations. And this means that the model predicts something that's incorrect, but is very confident about this. And we will see an example of this later on. The other thing is overfitting. So these models are trained on lots and lots of data, and sometimes they just literally replicate the input data on which they were trained. And if this input data was sensitive for some reason, for example, this can be problematic, of course. And also it leads to poorer generalization. Bias is a problem. If the model is trained on data that is inherently biased, then there's a good chance that the model will also be biased. So we should really take care of that. They're sometimes difficult to control. And now a lot of the people are focusing on this prompt engineering, so that you get the right prompt. With the right prompt, you get the right output. But you can see that this kind of prompt engineering is now already embedded into GPT, for example, and it's getting better and better. But there's still some improvement to be done. These models are also difficult to really understand how they function. Often it's a complete black box, and people often want to know how this works. So this is for us still an issue to work on, despite the fact, for example, that we also don't know how the brain works, and we don't care about that. We still work with it. Another problem is over-reliance. So these models, they are very intuitive to work with, right? So the natural language with which you communicate to it, the natural language that you get back, it makes it so personal, and we start to and because these models are also so powerful, we really start to trust these, and we should still be careful because of all the other issues. Ethical concerns, of course. These models, they can generate kind of obnoxious output in some cases. Creative concerns as well, right? You hear a lot about these copyright infringements. If they're trained on copyright data, they can generate new kind of output that is also, it's questionable in terms of copyright rights there. Fake news, right? These tools now, everyone can use them. They're very powerful and makes it very easy to generate fake news. And this is already happening, and this is something to take care of. And the high cost. Not only to train these models, these are huge models, but also really to deploy them. These are very costly, and most of the companies that are actually working with these models, they're losing profit right now. They're not making any profit. This is mainly because it's too hard to really deploy them in an economical way. And we as a company, by the way, are working on that, and I'll show you some of that later on. So an example of an hallucination, and I got this example from Mieke de Ketelaar, who is an AI specialist in Belgium, where I'm from. And the question I asked ChatGPT is very simple. What is the product here of 975 times 538? ChatGPT gave me the answer, but it was completely wrong. So I asked, well, are you sure? Because I have a test tomorrow at school, I want to have good grades. So here I asked the model again. It nicely splits up this product into smaller subproducts, but all of the responses are actually wrong again. So then I said, but are you absolutely sure? Because I want to have good notes. And ChatGPT is very confident about this. Yes, I'm confident. Gives me again the wrong answer. And then finally, I even provide the answer to ChatGPT, but it's still wrong. So here, this is a typical example of a hallucination. But the good thing is that these things are already being solved. If you look at Bing Chat, this immediately gives me the correct answer. And the reason is that Bing Chat is really trained to use additional tools like calculators and so on. So these models, I think part of these problems, they will be solved in a relatively short time. So one of the other things is that these models, people always say, they're actually not really intelligent. or creative. And here's this nice quote by Douglas Hofstadter. You may know him as the author of the book Gödel, Escher, Beck. And he basically says here that, well, these models are trained on lots and lots of data, and the only thing that they're doing is to predict the next word. And that's totally not intelligent and also not creative. So, well, let's put this to the test, right? You can actually ask these models to do a creativity test. And some people have done this. They took the TTCT test, which is a particular kind of creativity test. I had never heard of this before. But apparently what is supposed to be done here is that you imagine that a hypothetical situation is true, and then you think of the consequences this situation would have, and you give some solutions for problems that arrive in these situations. For example, suppose all children became giants for one day out of the week, what would happen? And if you ask this to GPT-4, obviously something that they haven't seen before during training, at least very likely, then it gives a lot of answers that touches upon economics, psychology, cultural phenomena, and so on. And pretty good responses. And if the responses are then scored by human scorers, GPT-4 scores within the top 1% of all the test takers. So with this definition, at least, of creativity, GPT-4 is already creative. But you could say, well, that's not the type of creativity that I have in mind. For me, creativity is something more arty, some paintings or so. But even there, right, there are some examples at least where these AI models, they do really well. Recently, this spiral medieval thing that became viral on different social media. This image here won an art competition prize, and only later on it was discovered that it was done by an AI algorithm. So whether AI is really creative or intelligent, okay, that's still open for debate, but at least it's making steps towards it, and it's a very useful tool in this context already. Last thing that I would like to mention is, and I briefly mentioned this already before, is that these models are super large, and also when it comes to the number of computations that need to be done for one inference, which can, even for a smaller model like GPT-3, be 10 to the 15 flops, which is quite a bit. And this is a real challenge. This also relates to the costs of these networks, and that needs to be tackled, also for environmental purposes. So this is generative AI, and we have looked at some of the problems related to it. Now let's look at the solutions. What can you really do with this type of technology? And when you think about AI, you automatically think about automation, right? It can do a lot of things for us. And it turns out that is especially true in more the STEM professions, education, but also in legal kind of practices. And this may be surprising, but what they need there is really a good tool to summarize a lot of text. And these models are really good at that. And also GPT took the bar test and passed it. So apparently has a lot of legal knowledge also available. Where it's not so much influencing automation is more in like agricultural settings, but also in like production work and so on. So this new wave of AI is really affecting much more the white-collar jobs and not so much the blue-collar jobs. And that's a big difference with respect to other types of revolutions, like the industrial revolutions that we had in the past. So this same survey done by McKinsey also found that the 4 applications where generative AI will generate the most value is customer operations, marketing and sales, software engineering, and R&D. So let's look at each of those individually. For customer services, chatbots are becoming very important. And there is this company called DoorDash that will observe that a lot of the phone calls towards takeoff restaurants, they are actually unanswered. And they made a chatbot that they call Dash AI to really answer all these calls and even make suggestions to complement their orders. So this can, of course, lead to a big increase in the revenue of these companies, and is a very simple problem that's already being solved by these tools. Now, for marketing and sales, automatic website builders are already present. And this can help like people in marketing to really experiment with different kind of website setups, different kind of media that they add to it, and even just build a network, a website from scratch. And here are some tools that can be used, for example, in these situations. So, software engineering, we've seen some example here, building the website from scratch, and we will see some more later on. And is also expected to become like a major market for this type of application. So the expected annual growth is about 22%. So it's going to be a very important kind of market to focus on for generative AI purposes. And when it comes to R&D, there's this interesting quote here from a well-known Google engineer that in 2019, he quoted that he predicted that the computer system would match or exceed the problem-solving abilities of the best human mathematicians within a decade. And last year, he revised this prediction and set a new target date to 2026. So basically what he's saying is that within 3 years from now, he thinks that these generative AI models will be better than the best human mathematicians. And that would be a major feat, right? Because we always think that mathematics is one of the most complicated things that we have invented as humans, and is also one of the most, well, productive tools that we have for new inventions. So it would be a very big change for all of us if this would be true. If you look at what the models can do right now, so if you let GPT-4 take the math SATs, or standardized test in the US, it already scores among the top 10% more or less of the students. And these are, of course, not professional mathematicians. These are still students, but it's still quite remarkable what these models can do. And here's an example of this. So the question here is, well, the greatest common divisor of positive integers m and n is 6. The least common multiple of m and n is 126. What is the least possible value of m plus n? I think this, well, it's already a tricky question, right? But what the model does here is it reads the question, it knows about a certain theorem here, the first theorem is given over here, it uses that, it writes some code to do some arithmetics, it enumerates a couple of solutions, and then it picks the best solution out of it and gets the correct answer. So there are already quite a bit of reasoning steps here involved, and also the use of theoretical knowledge here, which I think is pretty amazing that these models can already do this. Another R&D example is recently found by the collaboration between NASA, IBM, and Hugging Face, and they worked on an AI system that takes in satellite images and can predict where there are wildfires, floodings, or like deforestation going on, for example. So this type of AI can already help with combating climate change as well. So I don't think it's only in these 4 kind of applications that AI will prove very valuable. Actually, in gaming, generative AI is already becoming incredibly important in generating 3D assets, storylines, even complete worlds there. And there are a lot of venture capital firms now that are actually investing in startups that are working on generative AI for gaming. And then another field where I think AI will be very important is in medicine, in healthcare medicine. This is a typical example of these models that can really already predict where tumors are, for example, often as good as, or maybe better, as trained radiologists. But it goes even further, right? Google now has this model called MedPalm 2, which you can ask basically any question about a medical disease or medical conditions, and it will help you, will give you a response about diagnostical criteria, therapies that you can have in these situations. And these kind of models, they can become very important in like environments or locations on Earth where no trained doctors are available, and this can then really help out there. But you can even take this a step further, right? So nowadays you can record brain activity, and in quadriplegic patients, so these are patients that cannot move their arms or legs anymore, you can restore some of the feeling and some of the motor activity there again. And this is how it looks.
So Keith's brain is literally connected to a computer. There are signals from his motor area responsible for movement going to the computer, and signals from the computer are going back to different stimulation points in his body, brain, and spinal cord. And the goal is to restore movement and the sense of touch in a lasting way.
So pretty amazing. And you can even take this another step further and use brain activity with a simple stable diffusion model to predict what a person is seeing based on just neural activity. So here they recorded fMRI activity in occipital cortex, temporal cortex, and used that model in combination with stable diffusion to generate what a person is seeing. And here you can see some of the results. So on top are the presented images. On the bottom are the predicted images reconstructed from the model. And you can see that there's a close correspondence between the two of them. And this may sound pretty freaky, that you can start to read what you're thinking just by using brain activity. But on the other hand, it can also be very helpful for like locked-in patients, for example, who have no ways of communicating anymore with the outside world. They can use this kind of technology to really start and communicate again. So that's some of the things that you can do. You can do a lot with generative AI. But now I would like to talk a little bit about some of the implications that come along with it. And here it's interesting that according to a recent survey that said that 72% of the CEOs think that generative AI is a very important investment priority, even despite more difficult economic conditions. And they see the return of investment more on the mid to long term than on the short term. So already they're starting to think about how important this is and really implement this. But if you want to do this, of course, you also need to make sure that your workforce is properly trained. And here it turns out that according to a survey, that people want to be trained in generative AI tools, but about only half of them receives the proper training. So this is something I think to really keep in mind, that we have to start training the employees already right now. And not only the employees, of course, but also the students, right? We have to think about they are now learning, studying for a future profession. And we have to make sure that the knowledge that they learn, that is still relevant once they graduate and enter the workforce. And this is going to be increasingly difficult, especially because the pace at which AI is evolving is incredibly hard. So it will be a big challenge here to keep up. And I think in this morning's discussion, there was already something about this as well. So these are some of the implications. I think another thing is that this will be a new way of communicating with compute. And there's this AI startup here by some former Apple employees, where they made an AI pin. And I'll show you here what they do with it.
But for the human-technology relationship to actually evolve beyond screens, we need something radically different. Let me show you. Where can I find a gift for my wife before I have to leave tomorrow?
Vancouver's Granville Island is a lively shopping district.
That's an incredibly simple response for a very complex query.
So I think these kind of personal assistants and this kind of interaction with computers, so not anymore with your keyboard and your mouse and so on, this will really be much more and more be done with just natural language and other gestures, for example, in a very intuitive way. And you may even think that at some point, like operating systems, they will not be so important anymore. It's just going to be one big AI model that is running the whole compute there. And if you want to bring this kind of compute really towards these edge devices, like your phones or this kind of pin as they were using over here, then you also need to have the right compute resources for that. That's what we are working on. We have different kind of solutions for doing AI at the edge for smaller users, but also if you want to go towards like high performance, if you want to have beta ops of compute, then we have partnerships with Dell that can help you out. So I think this will be a very important thing towards the future. Now, general conclusions here. I think there's this debate, right, between people that are really afraid of all the implications that come with this very powerful tool, AI. And then there are the more techno optimists that really see all the capabilities. And recently in this blog post by Andreessen Horowitz, it was really nicely formulated, the two extreme poles that are out there. Some people think, well, there's a new kind of Frankenstein that's being developed, and this will be bad for the future, for our children, for the environment, and so on. And then there are the techno-optimists that really believe that, well, most of what we have in society is built on technology. And this is an incredibly powerful tool, and we should really use it, hopefully, to increase productivity, to increase society, and also to, well, do good for mankind. Okay, I think from my presentation, you will probably have noticed that I'm more towards this side, although I also think that there should be clear regulations. But I'm looking forward to hear more about what your opinions are in this respect. So thank you very much. Thanks.
Yeah, here you go. Any questions you would like to ask? Sure. Are you okay? Then I will throw the box and you will catch it. You're going to try it? Yeah, ready for it?
Hello. My name is John, and can you show me the title of your presentation again?
Not sure if it would work.
It's. I remember it's something about the next wave of
next
AI
wave of
systems.
AI is transforming the way we live and work.
And I noticed that directly when showing it, you redefined the next wave to mean the current wave. Yeah. And I tend to agree with Dr. Jan LeCun that these large language models are something that we will look back to after 3 years and think, oh yeah, well, that was a nice beginner's effort, but nobody uses them anymore, etc. So my question to you is actually, because you know all this, what will now actually be the next wave of AI?
You see a lot of... I disagree with the statement that we will not use these large language models anymore. I think they will be used, but in combination with other types of tools. Yeah. And what you see happening these days already is that these large language models are embedded into agents. And different kind of agents work together to solve a much more complex task with a particular goal in mind. And this goal-oriented behavior, that will be, I think, really the next wave of AI.
Thanks.
Someone else a question you can throw. Yeah. Oh, it's close by.
Hi, my name is Jolanda Duinhoven. Hi. I think you briefly mentioned the environmental impact of the models and the cost of it, and that you're working on that. Could you elaborate a bit on that?
Yeah. So a lot of these models are now being run into big server farms in the cloud. They are so large, they require so much compute that it has a very large environmental footprint. So what is happening right now is that people see that actually you don't need these very large models anymore. Actually, some of the small models with only like a couple of billion of parameters, they also do well, especially when you're focusing on one particular task. So that's one thing. Then you can also start to reduce these models even further using for example, quantization to a lower precision data format. You can do some pruning, compression of the model. You can even reshape the model in such a way that they run really well on particular hardwares. And then, of course, there's also such thing where you can improve your hardware itself to run much more efficiently. And we, for example, in our company, we have our own technology where we use in-memory computation. So we do the computations that are usually being done in a separate processor away from memory. We do it inside the memory. And because we do it like that, we are much more energy efficient, and this can really help with these environmental problems.
Okay, thanks.
Hey Bram, really nice presentation. I actually just have a question about the newest line of the Axelera AI products. I know you've been told me before that they are optimized often for certain neural network architectures, and I assume they have been doing that for transformers as well. If I would use Axelera AI chipsets for, let's say, training a Llama 7 billion, how would I go about this? Like, can I just go with a PyTorch implementation, or do I need to use your optimized toolkit for that?
So, good question. First thing is that we are specialized in inference. So the training we leave still for the cloud or on your own servers, but we are really focusing on inference. And for the inference part, you can just use PyTorch model as input, and we make it very easy for you to deploy it. We make sure that all the quantization, the optimizations that are being done, and you get the nice binary, and you can just start to run your own model. You can even start to build a pipeline of models by just bringing these together on our website, so a whole application can be built there. But if you are interested in really going into the nitty-gritty details, well, that's also possible. So we provide that possibility. Yeah.
Last short question then. What would the speed up be using your cards compared to the H100, for example, if for inference purely, such a model?
It really depends on how you compare. So what we are aiming for is a really powerful solution, but at very low energy or power consumption. So if you compare to a comparable NVIDIA kind of card in terms of throughput, for example, then we are a factor of 5 to 10 times more energy efficient, for example. And also when it comes to price, it's the same factor that's being used. So it depends on how you compare. If you compare to one of the Halo platforms that are a little bit slower, then we are both more powerful, but also more energy efficient. So it depends on your comparison.
Awesome, thank you.
We still have room for one question. I see we have two. Let's show in the back. Yeah.
Okay. Thank you. Do you see the models now being catering to a specific field of expertise? Let's say model for just legals or model for R&D. Is there a direction moving towards that?
Yes. Just 2 days ago, I was talking to a company that's really focused on that, and they adapt their models for really medical, legal, financial applications. And nowadays there are these nice tools to do this, like these LoRa tools, which makes it very easy to adapt your models for a particular kind of situation with a restricted or limited kind of training compute that you need to get there. So yes, it's going on, and it's also becoming much more and more efficient to do that.
Thanks. So we are end of time and ready for the next speaker. So first of all, thank you again, and give him a big applause, please.